the slobble. All right, so especially orchestra people, our homework is 12-2. Yes, it's Friday. Sorry I'm giving you homework. I'm going to give you lots of class time, but it doesn't matter if you're not here. So what do we know about every parabola? And really we can go back to what do we know about a ball in flight or objects that are falling. It doesn't happen if it hits the ceiling. But
I think that's an orange.
What happens when this is in flight? What point exists? What things occur? Say like in baseball or basketball or any of those things when you're trying to throw a ball to somebody else, you know certain things about it. Scrabbler?
Doesn't it have one point where it completely stops?
It's got what?
It's got a point where it completely stops.
Yeah, now this, it's a little tricky to say that, but it's a very, 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 like the blink of an eye, a bit of a second. It's motionless because of gravity. Now that is when it goes straight up, straight down. So when it's arcing, it stops the up-down travel, but it'll still be moving left to right, but it's not changing vertically. It changes, it then like from going up, stops going up or down, then starts going down. What else were you going to say, Seth?
I was just going to say it's losing speed on the way up and gaining speed on the way down.
Okay, yeah, so it's essentially decelerating all the way up, then accelerating all the way down. If I want to throw the ball back to Sasha, where should my highest point of the arc be? If I'm going to toss the ball like this, where would the highest, obviously I need a better toss, but where would the highest point need to be? Greg? Halfway between. Why? Where was my highest point on the throw I just threw?
Third.
Traveler?
Oh, like a little bit less.
Yeah, it was less than halfway, which made my arc go less than the distance I wanted. So every arc that we see is going to have some point at the very top or the very bottom that is the halfway point, and that point creates an axis of symmetry. As we saw, whatever day it was, Tuesday, when we were making parabolas, if I have a few points on the left-hand side, I can mirror those points on the right-hand side because I know the whole thing is symmetric. So without further ado, part 1 goes over how we find the axis of symmetry. I guess I should probably capture this. So the axis of symmetry can be found through a fairly easy formula, but the first thing I would write down in your notes, Ben, where'd you leave my copy of notes?
There was a whole stacking, so I put it in the folder.
Because of people missing?
Yeah.
So I would highlight, circle, or star the fact that, and I think I gave you these, or did I miss out? No, because I give this to you elsewhere. So in part 1, highlight, circle, star. Do something to remind you. We've got a in front of our x squared, b in front of our x, and c is our constant value. Because to find the x value of your axis of symmetry, that formula, and it's given to you on your paper, is just...
In this problem, you will graph a function of the form y equals a times x squared plus b times x plus c. What is the graph of the function y equals x squared minus 6 times x plus 4?
Here. And this. The fact that our quadratic, ax squared plus bx plus c, coefficient to my x squared is a, coefficient to my x is b, my constant is c. So, number 1 is done out for you. So I want you to look through number 1 and tell me, is there anything you don't understand about the process that they're taking just to get to this point? They pull out the b is -6, so the negative of -6 will turn into +6. Then 2 times your a, well, I don't have a coefficient, so we know it's actually 1. So 2 times 1 becomes 2. And that just gets me to x equals 3. Anyone confused by how we found the x?
No.
Now, if we go back...
Yeah, why is there no C?
Because the c is not involved there. There is a c. My c is 4, but I don't care about it.
Okay.
It's not involved in finding your axis of symmetry. Because now, why would the c not be involved? That's a good chance to stop and ask why. Mackenzie? We'll look. Give me just a second. Why does the C not matter, Emily?
Because the axis of symmetry display vertical and it just moves it up or down the C.
Yeah, your C value is your vertical change. So it's not part of your axis of symmetry because it doesn't affect your axis of symmetry. If I have a parabola and I move it up, that axis of symmetry is still where it was. If I move it down, that axis of symmetry is still where it was.
That makes sense.
So then, when we know the x value of my axis of symmetry, and it's easier when you look at the parabola. So if you look down your notes to this next area, well, so Grant, to answer your question about what is the axis of symmetry, that tells me where either the minimum point or the maximum point is. And that tells me that whatever's on the left of it can be reflected on the right of it, or vice versa. Whatever's on the right of it can be reflected on the left of it. So in a perfect y equals x squared parabola, what is the axis of symmetry?
0.
Well, what equals 0?
C.
Not
C.
y equals 0, x equals 0. Because really, in y equals x squared, the axis of symmetry is your y-axis. It's that vertical line y-axis. Because when we looked at this on Tuesday and we started plugging in values, 1 squared gives me 1, 2 squared gives me 4, 3 squared gives me 9. I can do the same thing on the other side. Here we do the same thing, except because my parabola has been shifted, when I find the x value for my axis of symmetry, I can find my minimum or maximum point by just plugging in that x value everywhere we see an x. So I take my x equals 3, I replace it there, and this now tells me my y equals -5. That gives me the point 3, -5 is either my maximum or my minimum. And then if I shift left or right of that point, whether it goes up or down tells me whether it was the maximum or the minimum. Yeah. Let's try one, because then it's going to make more sense. So when it's all shown out for you and you don't have to write anything, there's not as much, like, you don't absorb it as much. So let's try the got it there. We're going to do this together, even though it's a got it. We're going to do this one together. Because this is all here for you to be able to reference any point. I'd rather us talk about ones that we need to solve. So we have our graph here, and I've edited the graph to be what you need. We know, and you want to write down first, to find my axis of symmetry, x equals -b over 2a. I identify that my b is 4. Any issues with that? My b is 4. I look at the sign in front of it, because if that was a -4x, my b would be -4. So I plug in -4 over 2. My a is -1. Because it's minus x squared, my a is -1. Any issues to here? So then I just simplify this. This would be -4 over -2. That gives me a +2. So that is the x value of my axis of symmetry. So on your graph, draw a dotted line at x equals 2. Anytime you have an x equals, it will be vertical. It's going to draw that dotted line at x equals 2. Then we want to find out my vertex. To find my vertex, we plug the x into your equation. So plug in x. So I say y equals, well, -2 squared. Now pay attention. The x squared will happen before the negative happens. So we can even write it like this, but you have to remember the square happens before the negative happens. You got to follow the order of operations. Parentheses, then exponents before we ever get down to subtraction, which is where the negative really applies. Then plus 4 times your 2, and then -2. This becomes 2 squared is 4, so we get negative 4 plus 8 minus 2. Work your addition subtraction from left to right. Negative 4 plus 8 gives me positive 4 minus 2 gives me 2. So now my y equals 2. That tells me that if my x is 2 and my y is 2, then my vertex is at 2, 2. Do you, Greg?
Kind of.
Can you walk? I'm going to clear this. It's up on the TV. I've run out of space. So I'm going to clear this. Yeah.
Just look at the vertex and then look where you put it.
What do you mean?
You put it right on the name line.
I know. I've run out of space. I got nowhere else to write. So I guess I'll leave what's on my graph over there. Any questions up to now for how we found the vertex? Are we good with what we did? We found the x and we plugged it in. Grant? Oh, sorry. Thumbs up. All I saw was your arm. Now, Greg, what do you think we need to do? We know where the vertex is.
Oh, never mind. I don't know.
How do I figure out, aside from the fact that I cut the graph how I did, how do I figure out whether this is a maximum or a minimum? I mean, you could guess it's the maximum.
Because you put it like that.
Because how the graph, but that's not how it's going to be on the test. On the test, you have like a 10 by 10 or something where, well, you don't know. So your next step is to work left or right, you choose, from the vertex. Getting a little dyslexic. Which do you think would be easier? To choose 1 or to choose 3? Greg? 1. And 0 especially will be easier. So make x, or in math we normally say let x equal 1.
I thought it was let x be 1.
Yeah, I mean b is just another way to say equals. So you can say let x be 1 if you want. Then y will equal, well, the negative 1 squared plus 4 times 1 minus the 2. This is negative 1 plus 4 minus 2. That will give me 3 minus 2, which will give me 1. Which tells me that at 1, I should have this point at 1. And because the axis of symmetry reflects everything, I also know there will be a point at 3, 1. You got to go at least 1 more point, normally 2 more points. So let's just skip over 0. It'd be pretty, well, okay, if we do it real quick, 0 squared is 0, 4 times 0 is 0. So when x is 0, what's y? 2. You should be able to figure out negative 2. So when x is 0, you just have that constant value for your y. So now let's let x be negative 1. So now we'll have y equals negative 1 squared plus 4 times negative 1 minus 2. This will still be a negative 1. This turns into minus 4 minus 2. Are we with me? Are we? Cool. So then this gives me a y value of negative 7. So now at negative 1, I should be at negative 7. I forgot to reflect my point at 0. So if I have to go 2 to get back to the axis, I go 2 on the other side of the axis. Here at my negative 1, negative 7, I have to go 3 to get back to the axis. So I go 3 on the other side of the axis. And then I connect them, and I sketch, because parabolas are hard to be perfect, but I sketch what the parabola would look like. Not too bad, right? You just have to work a few x points. Once you find that vertex, everything gets easier. Questions?
No.
Now, where this is really going towards, because a lot of you, I mean, you're smart people, you wonder why the heck are we doing this? When things have conical shapes, so round parabolic shapes, say a satellite dish, or a headlight or a flashlight or anything like that, there is a focus point, and you have to know how to do the math. So a satellite dish, has anyone ever seen like an actual satellite dish?
Yes.
It looks like this, and then it normally has a part that comes out and like points into it or something. And this is all like concave in, which I'm really bad at like drawing that stuff. But there's some point within that bowl that perfectly focuses everything that reflects in there. So it's picking up all these waves that are floating around through the air. It picks those up, focuses them, reflects them up into the receiver, and that's how you watch TV or send an email or talk to the space station. The only way that we know how to make these satellites work is knowing where that focus point is, which we find through our parabola. Because there's some point within this space where all of the lines that come into here, all of the rays focus. Now, because this is really steep, we know our focus point would be further away. When it widens out, my focus point gets closer. And we're not doing focus today. I'm just letting you understand why we're doing this. Any other questions on that? Got it. All right, so check out the problem 2. I want you guys to try this on your own. We want to know what is the range of the function that models the height of the t-shirt, so how high can the t-shirt go? And how long will it take the t-shirt to reach its maximum height, which if we think about it arcing, would just be the vertex. Its maximum height would just be the vertex.
In this problem, you will use the vertical motion model. During halftime of a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach its maximum height? What is its maximum height? What is the range of the function that models the height of the t-shirt over time?
Starts 5 feet up. So, and we've made a slingshot like this. It never really worked that well. But you're never going to start a slingshot on the ground. So you're always going to start at some y-intercept. Now, would this have to go to 5 feet on the other end if you're shooting something up into the stands? No. So that's why it doesn't ask you where does it end. It asks you where's the maximum height. And this is like, who's ever been to like a Blue Jackets game or a Cavs game or any game where they're like shooting stuff with cannons or what? Yeah, this is what they have to figure out. If I want to shoot a shirt to somebody up there, I don't point the cannon there. I point the cannon way higher because it has to arc higher than them and then drop back down to them. Or you're going to shoot them in the face and you'll probably lose your job. So,
It'd be kind of funny.
Yeah, I think.
I mean, I've thought about that many times. I have a potato cannon. It was pretty dangerous. Yes, that's where that happened.
We've had potato cannon wars.
All right. Anyone want to talk me through this? Anyone feeling confident?
Hayden Garrett to the office, please. Hayden Garrett to the office.
Well, Jacob and Leon aren't here, so Jacob and Leon.
So step up. You want to help me find the axis of symmetry?
I mean, so I'll go for it, but I have no idea what I'm doing.
No one volunteers. I'm just getting out cards.
Okay, I'll try.
You want to try it?
You made a noble sacrifice, Greg.
Let's see.
Why do we have t equals here?
Because time.
Yeah, because instead of x, we're using t as my variable to represent time. So because t is my variable in the equation, that's what we use. So then negative b over 2a. So what is your b value, Greg?
Let me find it.
It's the coefficient of your
16.
It's the coefficient of your just x or
B.
just t. What comes in front of the just t? 72. So this is going to be the opposite of b, so negative 72. Our a is the first coefficient in the formula or in the equation. So what's our a here? Negative 16. Thank you, Grant. I evaluate this. I have negative 72 over negative 32. What'd you get? 2 1/4. So that tells me it takes 2 1/4 seconds for my shirt to reach the maximum height. Kind of. I mean, 1 1,000, 2 1,000.
But that's like
They're,
a shirt.
it's a pretty powerful cannon, probably, for it to stay in the air that
Yeah.
long.
It's not really a cannon, it's a slingshot.
Or yeah, so I was thinking when they. I mean, either way, it doesn't matter whether it's a slingshot or a cannon or tossed by hand. It makes a parabolic arc.
Yeah.
So then to find the h coordinate, because h is now like my y, it represents what the function equals. What do? How do we find the h coordinate? Someone knew. E.
You gotta plug in T there again.
Yeah, we take the t value that we found and we plug it in. So, and my work is probably going to take up more space than yours, so hopefully you have space on your paper. H is going to equal negative 16 times 2.25 squared plus 72 times 2.25 plus 5. 2 1/4 squared.
2 and a squirtle.
2 and a squirtle. Anyone do that yet? 2 1/4. 5.0625. Then let's go ahead and multiply it by the negative 16,
Over your arm.
please. Negative 81. So I was saying please to Grant because he said move your arm.
I wasn't
Excuse
done
me?
with my sentence. I didn't say period.
2.25 times 72. 162. So h, when I combine all of these, 86. I don't know. Because they told me the answer.
81 is half of 162.
And then you add 5.
Yeah, I see.
Questions, comments, concerns? Does this make sense to us? Try the Goddard on your own. And then that's the end of our lesson. Huh?
Every time we say we get it.
Yeah, then you try it on your own and
I understand every answer you give me without me having to work on it.
so remember what I said, and you may have not been paying attention, but that B term is your initial velocity. The A term is gravity. T-shirt is caught 35 feet above the court. How long does it take for the t-shirt to reach its maximum height? I think we're assuming the same slingshot from before. So now the difference is going to be, instead of an initial velocity of 72, the change is that our initial velocity is now 64. And really, you might want to start getting in the habit of saying h of t, the height at time. Because that h is relative to what your t equals. Are you being sarcastic? For real? Yeah. Who knows what I need to do to my equation to solve what they're asking me to? Because I don't have a time. I don't know what the time is.
Oh, I know. You got it. Isn't the height at time 35?
Yeah. I don't know what the time is, but I know that the height is 35 when it's caught. So I can replace my height with 35 and just say, oh, 35 equals negative 16 t squared plus 64 t.
Why no time?
Oh man, I got wrecked.
I know, right? Wait, why didn't we just do that in the last one?
Because we didn't know the height in the last one. In the last one,
Yes, we did.
Yeah, we did.
We knew the initial height. We didn't know the height where it landed.
No,
Yeah,
it
this
says
is
now
not
we
35
did.
feet above the court.
It says 35.
Up there, yeah, it does.
It says it for both of them.
Boy.
It's right after the 35.
Oh yeah, so we could do either way.
We got
Then how we get 86? What? What is 86 people then?
That's the maximum height.
Oh,
We
okay.
found the
I got
maximum height. Then it's caught at. So we could really the purpose was I'm just trying to get through this fast. Really the purpose was to solve it both ways. Solve for the max height, then solve for how long it took. Because that 2.25 seconds, that's the half its distance. It will not travel the other half of the distance because it's caught higher than that. So what we were going to see is that other time would have been less than 4.5. We can go back and solve it again if you guys want, but that's why I just moved on to this one. We could again solve for the maximum height if we solve for the axis of symmetry, so your t value, then you plugged it back in. But instead of doing that, we just do this. But now, how do I do this?
You subtract 5 from each side.
Sure, I'll go ahead and follow you guys. 30 was negative 16 t squared plus 64 t.
Why did you follow us?
Because that's what you guys told me to do.
Okay, so then you
Think
divide
about last chapter maybe. Divide by,
64. I actually have no idea what I'm doing. You divide by 64.
not at all. 30 divided by 64 would get
Take the
really
square
messy,
root
and
of
so would
30.
this. Seth?
I would divide by either t or t squared, and then just
But then that's going to put t on the other side.
and then move 30 onto the other side.
We don't want to put t in more places. Think back to last chapter. Why might we have dealt with factoring quadratics prior to getting to our quadratics here? What does factoring the quadratic actually give us?
Divide by t.
That would again move the t to the other side. Now we could factor out the t. That wouldn't be dividing by t, but we could then say t negative 16t plus 64, and we could actually factor out like an 8t or something like that. But still, none of that really helps me. What if I moved my 35 to the right side? What if instead of subtracting 5, I subtract 35, and I say 0, I'm actually going to change color since I'm changing what I'm doing, equals negative 16t squared plus 64t minus 30. We can factor this quadratic and find my zeros.
Is that what you meant when you said no?
I didn't realize the first question they asked us is how long does it take to reach the max? Sorry, I skipped past the fact that they wanted us to find the maximum on this one also. So I was jumping too quickly through the problem. Sorry, when I try to rush, I get messed up sometimes.
Do it.
Yeah.
You're not
So-
human. Or you are human.
Thank you for correcting yourself, otherwise I was going to be concerned.
You're not human.
So again, if you want to find the max height, you first start out by finding your axis of symmetry, plugging it back in. So that gives us our max height. But then when we how far above the core level will it be? What is the range? Okay, sorry, I was trying to make this too complicated. We will get to what I was trying to do next week to show you guys, if you care. This would turn into two binomials. We'd have, like, say, a negative 8. Actually, what would be easy is make 4t and 4t, one negative, one positive, and go from there. But then those values give you your zeros of the function, which is what we're headed towards next week. Sorry, my brain got ahead of what we're actually trying to do today. Yeah, my head got a brain of myself. So really all that we're practicing today is finding the axis, plugging in that x value to find your max or your minimum. So are we okay with finding axis of symmetry and plugging it back in?
Yeah.
Hopefully. Because we're going to have to go over this again next week. I know we will, for all the people that aren't here right now. Or who all are we missing? I know Jacob Leon.
So McKenna might need help. The other two, yeah, they got it. It's not racist. I'm just saying that they're super smart.
That couldn't be. Oh well, yeah. They're both safe.
Don't miss the ground.
Well, yeah.
All right, then if you need to finish a test,